Welcome to Geometry Lesson 1-2. This is our second real geometry lessons talking about line segments and finding distances. Now, first off, you need to understand the difference between a line segment and a line. A line segment is written like this. There are definite ends, and those definite ends are A and B. The line segment only goes from A to B. It has a definite distance. A line is indefinite. Hopefully you have that down in your definition that you got in your notes from yesterday. Now, if we have a line, we can't measure it. If we have a line segment, we can measure it. So we do this from time to time. In geometry, you'll be asked over and over again, how do you find how far this is? How do you find how far this is? They're all line segments. It's something that we can define. Most of the time, you're going to be dealing with a number line to start with. So let's say we have one that starts here at 5, and it goes off to 8, and we'll say that this is A, this is B. All you have to do is either count or subtract. We go 6, 7, 8, or we go 8, 7, 6, 5. Either way we do it, we find out that the distance of this is 3. Now sometimes they'll have A, X, and B on that line segment, and X will be over here, and they'll tell you the whole thing is 5, and from A to X is 2, so how far is it from X to B? Again, we just need to know how to add and subtract. So if the whole thing is 5 and this is 2, that must mean that this part is 3. It gets fairly simple when you're doing things like that. Then they start to get into the coordinate plane. If we have a point in space that's labeled 0, 3, and we have another point that is 4, 0, they want us to use what's called the distance formula. Take the second x, subtract the first x, square it. Take the second y, subtract the first y, square it, and then take the square root. But actually what this is an adaptation of the Pythagorean theorem. We can draw this as a triangle, a right triangle, and just work out the Pythagorean theorem. If we were to do that, 0, 3 is up 1, 2, 3. 4 zeros over 1, 2, 3, 4. So here is my right triangle with a side of 3 and a side of 4. 3 squared is 9. 4 squared is 16. I add those together, I get 25. The square root of 25 is 5, which means the distance from A here to B here is just 25. This is applicable for any point that they give you in space. The only other thing that we'll need to worry about is a construction. They'll ask you to create something that is exactly the same distance. When we need to create something that's exactly the same distance, we will use a compass. If you don't have a compass, I have some for classroom use, so we'll be using those on the paper if they ask us for use of a compass. So if they give me a segment that is this long, the way that a compass works is it draws a circle. And the neat thing about a circle is every single radius of that circle is exactly the same distance. So if I set my compass like this to draw a circle that would go through here, all then I have to do is make another point here, and from that point with my compass at the exact same setting, put something down there, and any point on where I've drawn that circle will be the exact same distance as what I have here. It doesn't matter how I put together. Now, when you use a compass, it's very important to use it accurately, to use a straight edge. We'll go over some more compass usage when we get into class and we go over that kind of stuff. They're not going to do a lot of construction here at the start. It's going to be mostly adding and subtracting, but this is how we are going to find the distance. Now, I would like you to add definitions from the book to your notes for the distance formula and have what it looks like on there and add in the Pythagorean theorem under the distance formula.